Hello, I'm Jacob Young from the University of Otago in New Zealand, and I'm going to be talking about a virtual reality geoscience training tool I developed with my colleagues over at the Victoria University of Wellington. So this is a collaboration with the School of Geography, Environment and Earth Sciences, and a big part of the undergraduate courses revolve around field trips, which is where students go out and learn some physical skills they'll need for higher education and for working in industry later on. I'm not a geologist, so I'll let my colleagues over at the school talk about that a wee bit more.
So we're in Tamuna in southern Wairarapa, so it's a bit southeast of Martinborough. And we're here with a bunch of geology students, and they're learning how to make a geological map, how to interpret landforms.
It's their interpretation based on the skills they've been learning, but they're not just mapping the rocks, they're trying to understand the Earth history that's recorded in all of those layers. So we've got these limestones with scallop shells in them. It's telling us something about Earth history. It's telling us about climate change in the past.
So, as much as I'd love to do these trips every week, unfortunately, that's not really realistic. And what ends up happening is that these trips really only happen 2 or 3 times a year. And then the obvious downsides of this is that if a student is sick, they've basically missed their opportunity for the next 6 months or so. Or if they're injured, students with any physical disabilities are quite limited because some of these outcrops are quite hard to get to or have quite uneven terrain. And then the issue that really brought a lot of these issues to light were the COVID lockdowns, which were famously quite effective but quite strict in New Zealand, and essentially meant that these trips couldn't happen for a year or so. And of course, the other issue is that with the infrequency of the trips, students quite often forget the skills they learn between each one. So the lecturers over there were finding that second year students were coming in and they'd forgotten all of the skills they'd learned in the first year, and they'd essentially have to spend a whole trip just reiterating those skills and trying to relearn them. The solution was to find ways that they could kind of emulate these from the university. So this wooden platform on the right here is one thing they came up with to kind of emulate a sloping rock surface that students can measure, but it's not really quite the same as the real thing. So we thought, can we virtually replicate this field trip somehow? Can we actually get the experience of going out to the field and learning these skills in a way that's actually intuitive to students? And so this has worked in a lot of other fields, including medicine, dentistry, psychology, where they found that VR training can actually be quite engaging, quite effective, and can have higher learning outcomes than just reading a book or watching a video. And we've also seen some interest in using virtual realities for geoscience education in particular in the last couple of years. So there were a few different desktop-based systems, and then in the last year, really only 2 or 3 years, we've seen some virtual reality systems begin to surface. But one thing that we haven't really seen is whether the skills learned in these virtual environments can be replicated in the real world. If I learn a skill with a virtual rock, can I then go and do that same skill with a real rock? So we created some learning modules so students could practice these skills or learn the skills for the first time. So we had some virtual tools that students could use. We created some 3D scans of some rocky outcrops using photogrammetry, and we recorded some 360-degree video with the lecturers over at the School of Geosciences going over some of this content. And our main focus was teaching strike and dip, which is quite a fundamental skill. So if we have a rocky surface that's formed at a slope, we want to measure what the slope is and the angle that the slope's formed in. And then if we do that at a few different spots around the outcrop, we can learn how that rock was formed. So it's a fairly basic skill, but it's pretty fundamental to a lot of the mapping that the geologists do out in the field. So these lessons we developed basically consisted of 360-degree video of one of the lecturers talking about the skill or demonstrating how to do it, followed by a short interactive task where the student had to repeat it. So here's just a wee snippet of one of those lessons.
To read the bearing, we need to use the little tick mark at the base of the mirror. And what we do is we rotate the dial, and the useful saying here is red in the shed. So we want to overlap the red magnetic needle with the red on the base plate, red in the shed. So if I do that, keeping it as flat as I can, I now have the measurement that I want to use.
And so as you can see, the student also gets feedback. So in this case, they have a green tick showing them they did it correctly. If they did it incorrectly, or if they give a wrong answer, the system will actually tell them what they did wrong. we wanted to test this, and we were mainly focused on whether these skills would transfer to the real world. So what we did was we took a second year class of geology students. So they were ones that had done this specific measurement before, but probably hadn't for quite a while. First, we did a pre-experiment competency test. So we essentially got them to perform the measurement using that wooden podium on the right side, gave them a score out of 10. They went through the virtual training module, and then finally we repeated that real world test again using a different surface. So there were different angles. They couldn't just repeat their answers from the first time. Again, marked them out of 10 and just saw how their competency improved. And the results are quite promising. So if you look at the left-hand side, we can see their average scores out of 10 for the pre and post-experiment tests. For the experiment, they got an average mark of around about 8. The lowest mark we saw was a 2 out of 10, which was a bit shocking. And then after the test, average moved all the way up to around 9.5, and the lowest we saw was 8. So that's quite a significant improvement in how confident they were in performing this measurement. We also measured how long it took them to perform the measurement or complete the full test, and we saw quite a significant improvement there as well. These were second year students who had performed the measurement maybe a few times before, so that was more of a revision task, which is why we saw some students getting higher scores in the pre-experiment test. And we wanted to see whether this would also hold true for first year students who weren't quite as familiar with this task. There were a few differences, so we incorporated some of the feedback from the first test to improve the learning module. So we recorded some of the videos at a higher resolution. We added an extra step just to be a bit more consistent about the way results were being reported. And the main thing we did was that the pre and post experiment tests were actually done in virtual reality. So we wanted to see, we already had some results from real world testing. We wanted to see if the tool itself could be used as an evaluation tool so that students could get immediate feedback on how well they were doing. And then if there wasn't necessarily a lecture available, could we actually use this tool as part of the in-class testing? So it was the same procedure as before, pre-experiment competency test, went through the VR learning module, post-experiment competency test. So we didn't quite see the same results as in the first study. So we didn't see significant improvements in score or in the time taken to complete the test. There's a few potential reasons for this. First of all, we only managed to attract 7 students out of quite a big class. I'm not sure why that is, but it could just be that first year students aren't quite as motivated about any kind of extracurricular activities. And second reason being that with the competency test being done in virtual reality, there was actually an additional learning step required. So it wasn't just, can I do this measurement? It was, can I use VR effectively enough to do this measurement? So they were given a little time to practice with the tool. There was a specific, VR training module set up beforehand that they went through, but it doesn't, or it potentially wasn't enough to actually get them comfortable enough with VR to really reflect the competency. We also interviewed the students after each test and got some quite good feedback. So the main feedback we saw was that a lot of the students saw virtual reality as a good fit for this type of learning. They seemed to really enjoy it, and it gave them a better idea of how the skills they were learning actually applied to, the outcrops they'd see during the field trips, because we were accurately rendering those instead of that wooden podium, which a lot of students found kind of conceptually hard to transfer to a rock. Um, the other main thing we heard from the students and from the lecturers is that they don't think at this point that, no matter how good virtual reality is, it's never going to replace the actual in-field experience. They saw it as a great complement, but they think that, there's always going to be a requirement for actual hands-on in the field learning. Nothing's really ever going to replace that. Yeah, so in summary, we saw some pretty significant improvements in student competencies if they had already used the task before. So we saw that maybe this is a good way to revise skills rather than learn them for the first time. And especially since we didn't see the same results in our second test with first year students, it could be that virtual reality for this specific context isn't particularly good for first time learners. Um, and we also found a lot of support from students and staff that this would be a fantastic complement to field trips, but could never actually properly replace the real thing. There's some of the reference I used. Thank you very much for watching.